We'll see PV solar inverter circuit, that is photovoltaic solar inverter circuit using LTSpice. It's an inverter. So inverter is basically is do the function to convert the direct current to the alternating current. In our today lecture we will see photovoltaic solar inverter circuit. Okay. So what is a photovoltaic solar inverter circuit? Here the photovoltaic is biased with your biased using the sun. It is open exposure to the sun, so energy which is coming from your sun, it is fall onto the photovoltaic cell. So the energy is biasing your photovoltaic cell, right? That means the source energy is conversion is happening here. The light energy which is falling on the solar cell is converted into electric energy. That particular energy will be stored in the battery for the later purpose. Okay, the stored energy will be utilized for the inverter circuit. So this is the concept behind this photovoltaic solar inverter circuit. You have 5 different stages. The first stage is PV solar panel, and second stage is regulator and battery charging unit, and third is the inverter part, inverter circuit. From here you will be generating the switching pulse. Then it's a switching device. Switching device basically you will be having your MOSFET drivers, and finally you have a step-up transformer at a output stage. I have classified into stages of circuit. So first solar panel and regulator battery charger unit and inverter circuit switching pulse oscillator unit, and fourth is a switching device, and fifth is a step-up transformer. So as I said earlier, the solar panel is exposed to the sun. It is biased, right? You want to bias some energy. Here energy is you are getting energy from the light. That is from the sun. The whatever energy is coming from the sun, that is fall on the solar panel. So similarly, like a PN diode. In the PN diode, what you will be doing, you will be biasing with the external supply. Right here, it is stimulated with the light from the sun, which is generated from sun. No? So that will be the light which is coming from the sun, which is fall onto the solar panel. Energy is converted, like a light energy is converted into the electric energy. So such energy will be stored in the battery unit, and later it will be used for your inverter circuit. Okay, this is basically what happening in your inverter circuit. See, this is a complete circuit. I will explain. See, this is a solar panel exposed to the sun. So here the specific rating which I mentioned is 12 volt and 20 watts and 1600 milliamps. Okay, so it is connected to LM317. It is connected to LM31. It is a regulator part. So it is from here only we are taking the output, the regulator output, and this is an adjustable unit. You can see this adjustable unit, and output from the regulator is passed on to the Scotty diode. Okay, so this is so battery is not directly connected with your regulator, right? So it is passed via your Scotty diode. You can see it. See, this is a line which is not connected initially. When you want to switch on your inverter circuit, when power is switched off, right? In that time, this will be connected. There is a single pole, single throw switch will be connected. So the energy which is stored in the battery will be used for biasing your IC. Okay. So this LED for showing like this is utilizing your battery charge. So this CD4047 was biased with your this supply unit, okay, charging unit. Okay, basically this CD4047 can be used as a like a multi-vibrator. Okay, so it can be used as a multi-vibrator. You know what do you mean by multi-vibrator? So basically multi-vibrator is a switching circuit. It generates a non-sinusoidal wave, right? So like a square wave, rectangular and short tooth waveform. So basically people used to say it's a frequency generated circuit. So here we are making to work as a stable multivibrator. The functionality of here the IC will be working like a stable multivibrator. Automatically switch between the two states continuously without any external trigger pulse. Okay, so this another name for this stable multivibrator, free running oscillator. But when you go for other multivibrator, monostable and bistable, in monostable you will be having one stable state, one quasi-stable state. But in the bistable you will be having two stable state, but you need external triggering pulse. But for stable you need not to have any external triggering. It will be generating two continuous different state. Okay, that is a speciality in the stable multivibrator. Okay, so another thing you want to understand here is this is very important. So based on this only the frequency will be generated here. Okay, the full oscillation will be getting the 13th pin, and half of the duty cycle pin will be getting the Q, and other half of the duty cycle will be getting the Q bar. So output from this Q and Q bar will be given to this MOSFET switching circuit. Okay, so the signal which is getting from your MOSFET, that will be fed to the primary winding. Based on that, EMF will be generated. So that will be passed on to the step-up transformer, that is through secondary windings it was connected. You can see, correct. Finally, it will be because of this capacitor and variable resistor, output will be shaped as a pure sine wave. So you will be getting 230 volt output. Okay, so here so in our, when you are designing the LTSpice, the CD4047 and this LM317 will not available in the parent directory of the LTSpice. So you can do either two things. One situation is you can download from the net and you can add in the parent directory. Otherwise, we can add in the working folder. So I'll be asking to do working the second method. Okay, so I'll be showing same here. So what you want to do, you will be saving your main field, right? There you can save your supporting files also. This is very important. So wherever you are saving your main field, right? For example, I'll be taking like a week 10 or 11. That is your folder I have taken. In that I will be saving my schematic page. In that same folder, you want to add my supporting files also. Then only the that file which you are added in your schematic page, that will work. Otherwise, it will show some errors. Okay. So this is a basic part. So basically, you can see PV solar panel, regulator charger unit, and inverter circuit. The functionality is resemblance to the stable multivibrator, and switching MOSFET drivers. So finally, we will be having the output stage. So this is the main part you want to learn. Okay. So same thing will be try to implement in LTSpice also. So I said earlier, you can see given in the slides also. So the solar panel output voltage is directly fed to the regulator. Okay, so the regulator used to connect the output via Schottky diode. Okay, so the output is saved in the SLA battery. It's a sealed lead acid battery. So the ratings also is given here. So by adjusting the values, I can change the output voltage in the regulator from 1.25 to 37. Okay, the battery is connected via Schottky diode, and the DC bias to the inverter circuit is because of the battery. So that you are clearly understand from the circuit, right? So DC bias from the to the inverter circuit is via this battery. So another thing is this IC. This is very important. So CD4047. So here the highlighted pins are like a RCC pins, a stable multivibrator, and Q bar. This pins are, this is applied with the 12 voltage. Okay, this will work with the 12 voltage. So R means you can see here R is a connected external resistor to the pin between the capacitor timing and RCC. So R is a external resistor will be connecting we connected between C and RCC. Similarly, C is a external capacitor that will be connected between R and RCC, and combination of RC will be connected with the RCC point. Okay, so this is the thing you want to understand. By changing these values only, the frequency will be determined. Okay, the remaining things and all already explained. Q bar on 13th. On 13th, we will be taking a full oscillation output, and Q one part of say duty cycle, another half of the duty cycle from the 11th pin. So I said the formula is F equal to 100 by 8.8 RC. R is nothing but this point. R4 plus VR2, right? So where we will see this R4 plus this point. So R4 plus VR2 is your important. This is a variable resistor. Okay, plus the capacitor here is C3. So C is a C3 which you want to take for calculation. Okay, so as I said on the slides, 10th pin and 11th pin will be taking half of the duty cycle. So F equal to 4.4C RC. So the following output will be fed to the MOSFET drivers, and the finally subsequently your output stages will be passed on to the transformer. Okay, so this is LTSpice design circuit. So same we will be seeing in now. Okay, so here you can see here also separated solar section, regulated battery charging unit, inverter circuit, and MOSFET drivers and transformer. Okay, so now we will go to the LTSpice. See, now we will see how to design the solar power inverter circuit using the LTSpice. So this is the final design which you want to design from LTSpice. Okay, so now we will go step by step. Okay, the main thing I said, this LM317 and this IC 4047 IC will not available in the parent directory. There is a two case there. One case you can download from the net and you can save in the parent directory. Otherwise you can save these two supporting files in your current working folder. So I'll be explaining the current working folder procedure. Okay, so what you want to do is, so I'll show like a week 10 is your my working folder. In there I have saved all supporting files. You can see here. See, like this you also want to save. See, in the description page I have given all supporting files. You can download, and you want to extract. So the extracted file you want to copy. You want to extract and you want to copy in your that working folder, current working folder. Okay, don't forget. Okay, so I will be giving these files everything in the description page. Okay, so we want to copy in the same working folder, don't forget. Okay, so here in order to make you to understand, I have split it into the 6 circuits. Okay, step 1, step 1A, step 2, step 3, step 4, step 5. Okay, here you can see this is your reality. You have one solar panel. The solar panel get biased with your sun, right? So in simulation part, same situation you are trying to create. So the diode is exposed to this bias. So this bias is nothing but what we are assuming is sun. So this diode connected. Okay, see, actually here whatever I am using all are high power rating elements. Okay, same you want to use in your circuit. So when you search this type of element, see it is like see you will be finding 200 300 different type of resistor. It is very difficult to find. Okay, so what I suggest you is very simple method. So what I will do, just go here and delete it. Okay, you take any diode. Okay, you can follow same. Once you know the name of that particular component, I know the component, right? Already I shared this circuit for you. So okay, so RR1 LAM6, yes. Okay. See now, when you click, you can see it's showing the diode R1 rectifier. But shape will not be updated. Okay, I will save with some other element also. Shape will not be updated. What you want to ensure is, go here pick new diode. See, it will show directly to the particular element in your directory. This is a thing you want, right? So now you want to confirm OK. So now it will update it with the alpha quality. Okay, so this is very important. Okay, so now we'll go for the step 1 here. Here what I have done is I have connected the regulator, right? So regulator first pin, second pin, and third pin. This is the adjustable part. So based on this, in reality we have some variable resistor, but here I have connected some amount of resistor. Okay, so from this part only we will be getting the output, right, from the regulator. So the output of the regulator is passed to this Schottky diode. Okay, the Schottky diode output is passed through the battery charging unit, is passed via your Schottky diode point. So actually here you have battery charging unit, but in the simulation point of view I added this supply with the lower basis VDD. I will pass the value. Okay, that means 12 voltage will be saved here. Okay, so you can, another thing I want to say here is LM317 is not available in the parent directory. So already we saved in the new directory, right? That is a working directory. So go here. See, change, you can see the top directory, right? You change to the current directory, means that you have added, right? See, D is your current directory. See, there you can see these are the two model I have subsection I have added. So LM317. See, same you will be getting. So already I pasted, so I want to remove it. Okay. So I will show for this Schottky diode how to see. Very simple method. Go here. Choose any diodes. See, just you know the model number, right? Just type it. SS3P5. Only you can see name is changed, functionality is changed, but symbol not updated. So what you want to do is go to the pick new diode procedure and see it showing correctly the particular diode. Now you confirm. See, now symbol also updated. So this is the procedure you want to do. So what you have done is, this is your like a solar panel. This is a regulator circuit. This is a variable resistor part. From here only output voltage we are getting in the regulator, that is passed down to the Schottky diode. Following output is passed on to the charging unit. Okay, so here the three things are very important. So when you include the LM317, you want to add this directory. So you will add, right click and draft, go to the spice direct and add this dot include LM317.sum, same shown in the schematic page. Dot param VDD equal to 12, you want to pass your IC and this charging unit. Okay, so very important, don't forget this the supporting spice directory you want to queue in the schematic page. So to this clear, right? So in the step 2, what I have done is I have connected with the single pole single throw switch in order to indicate whether this is working in the normal line or inverter line. So when it is closed, that means it is connected to the inverter line. So that will be indicated with this LED. Okay, so this switch was biased with this 1 voltage supply. Similarly, see this switch will be you need this spice direct. Okay, that is dot model SW close bracket. Okay, this is a model you want to add in order to work this functionality. Okay, so you can see here. Okay, so nothing new in this. One thing is you add the same model. See, for this diode number is RR1LAM6S, don't add any other diode. Okay, so SS3P5 is your Schottky diode, and this is your charging unit, and this is a single pole single throw switch, and here RR1LAM6S diode, and this is your LED, same LED you want to connect. Okay, same procedure as I said earlier, right? So I don't think you have a doubt here. So in the third part, what I have done, so I have connected with your say CD4047 IC. So as I said earlier, the one pin is will be connecting the capacitor. You can see directly connecting capacitor, and two is connecting your this resistor part. Reality, you have some variable resistor, but you are not connecting variable part. You connected something like 400 kilo with the different option iteration I have calculated. And this third is a combination of 1 and 2 is calculated in 3. So you can see here this inverter Untitled circuit was biased with this battery, right? And this fourth and fifth one is a stable and inversion of stable. Okay, so we can even work like stable and non-stable multivariate here based on our function, based on our need, that can be modified. Okay, so the remaining pins to be shorted. You can see here, and 13 pin you are taking output from this vibrator switching circuit. Then Q and Q bar is your half of a duty cycle. Okay, so I'll show you. Okay, I think, see, another thing you can see, this also externally connected. So you want to connect, so go here and see, already it was in the new directory only. Top directory is 2, you can see C and D. D directory is a new subdirectory which is working current working folder. Okay, so you choose this CD4071B and keep here. Okay, already placed in the circuit, I don't want to repeat. I'll remove. See, another thing, this you want to add this dot include CD400.lib. This is the main supporting library you want to add. Okay, so this is a sub-circuit of this main circuit. So this is a very important to add. So once you want to work with the 4047 only, you want to add this directory also. Okay, and also you can see that dot param VDD equal 12, and I added this 2 parameter. So you can see where you want to add this. So already we have given only dot param VDD term, that you should be updated. See, just go here and add. See, dot param VDD 12 speed 1.0 and TRI PDT. So this is in reality you don't have such a parameter, but in the simulation part you want to add this actually. Okay, so you can add this like TR PDT, like I given the expression also, is a time change across the simulation step. Okay, is the instant parameter TR PDT can be set to stimulate the maximum time step size that simulator take across your state changes. Okay, that it will reflect in our IC also. When you change it outside, that will reflect here. So don't forget these other things to be updated. Okay, so before it was given param VDD 12. Now you have to be updated param VDD equal 12, speed 1.0, TRI PDT equal to 5 nanoseconds. So this to be updated. Okay, so when you run this, you can see the switching pulse. See, this is for Q and this is for Q bar. Okay. So now we will go to the fourth circuit. In the fourth circuit, what I have done, the output of Q and Q bar is connected to the MOSFET driver. You can see. So please ensure that whatever name is given, you want to give name same. It should reflect in your circuit also. Okay, any doubt you can post in the comment box. Okay, so it's connected to the MOSFET driver and connected another line to go to the windings. Okay, this is a part. Okay, there is no more new thing here. Just I connected the MOSFET drivers on the previous case. The 3 connected up to the IC, and 4th passed out to the MOSFET driver. The 5th, say connected to this winding. Okay, so you can see this is the primary windings and the secondary is the center tab 1. So it was mutually coupled with the parameter of KL1, L1, L2, L3. Okay, so here I have given the windings some series resistance also 1. Okay, for upper part, similarly for here also 1. Okay, for this very less I have given 0.1 milliohm. Okay, so you can see here this transformer to keep. So you want to go here and you want to keep a mirror. Okay, don't rotate. Okay, so if you rotate, you will not get the correct output. Okay, so the dot ensure that mutual coupling is happening. See, this show phase dot is locked. If there is no mutual coupling, this dot will be will not be locked. Okay, so that you want to ensure. So again I will say, see here it is a solar panel circuit. This is a voltage regulator part, and this charging unit is coupled via this Schottky diode, and this is your switching line, and this because of the switching line only it is biased this inverter circuit point. The output of this Q and Q bar is fed to this MOSFET drivers, and following output from the drivers is passed on to the driving winding point, and it is finally coupled to the second winding part, and these capacitors and resistors are used to shape your output to 30 volt. Okay, so that is some spikes will be reduced. Okay, now if you run, so you will take a couple of seconds. So I will be closing all. Okay, I will go here and I will keep vertical. See, this is your output you are getting 230 volt. Perfect 230 volt you are getting. Okay, same you want to get. So solar inverter circuit converting to the DC current to the alternating current. Same scenario we have obtained. So reality there may be some changes, but moreover you are reflected in the LTSpice circuit. Okay, the two things you want to remember, this regulator and IC will not reflect in your parent directory. You want to download from the description box and you want to add in your working folder. Otherwise we can add in the parent directory also. Okay, so in two cases you can do anything you can follow. So this subdirectory also you want to add in the schematic page, very important. So this also very important. So initially you will be adding unity control, then you want to update this to internal parameters. Okay, so we can try. If you didn't get the output, you can ask me in the next class. Okay, thank you.